A massive what up to you watching this video. This is episode 4.1, the continuation of the wiring harness modification. I just wanted to make some corrections and I guess instructions or just like notes for anyone else who wants to do this to your bike. So these are the things that I did to fix the warnings that happened. Okay, so the list of issues that I had to solve was the ECU failure warning, which actually it ran fine. And what that is actually completely inconsequential from what I removed. But I don't want my bike to say ECU failure every time I turn it on. So that one was caused because, and here's my notes. We've got my notes and then a panna cotta recipe, which I was going to tear out of this notebook. It's an old notebook, but you got to know how to make your panna cotta. So that's pretty key too. Anyway, so sorry for the mess. This has been, I mean, it's been a really fun time building the bike, but like, I think I've worked like 120 hours in the last month. And your boy's a little tired and been a little scrambled. So anyway, who cares? So the ECU failure is actually caused by this headlight unit removal, or sorry, the light relay removal. Headlight unit you can just unplug, and it doesn't seem to do anything. I guess I didn't test it solo, so maybe that does ECU failure too. I'll try to tag that in the title and description so that you can find this video if that's what you're facing. But mine was the light relay is how I fixed it. So what you need to do is at the relay box, which I have here in my pile. These are all the wires, everything that I removed from the harness, which like, I mean, I'm stoked on it at the end of the day because I just don't like all this jumble-y shit in my race bike because it doesn't need to be there. So your headlight relay is right here, right? And so the ECU, as it turns on, is looking to make sure that it has a headlight coil. And if it doesn't have a relay coil, then it throws ECU failure. I think KTM does that as like a liability thing so that if you don't have a headlight functioning at all, it just makes the rider scared, and then ideally you don't ride it. But we're stupid, so we're not doing that. So what you need to do is jumper the coil side of the relay, right? So these two little fellas, these two in the back, right now they're horizontal, those guys are the coil side of your relay, and that's your connector side, solenoid side, I forget what it's called. Anyway, so that's brown and white and purple black. You need to jumper that. I just used a 1000 ohm resistor. I got some 5-watt ones, which I kind of forgot that I had those, but I just used them anyway because, like, you know, maximum heat reduction. I don't think much current goes through there, but I don't really know. Anyway, so yeah, jumper those. So the purple black wire here is the signal wire that goes to the ECU, and then the brown and white is just a sensor ground bus that the whole bike uses. So you can see like the purple black here going straight to A11, or maybe that's the headlight. Either way, no, it does go to the ECU. Is A11 the ECU control module? Yeah, it is. Okay, so yeah, it goes straight to the ECU. So I just traced it back, and it's like right in here. So I took the purple black, and then I had a brown white that I just cut, and I put the resistor, I guess in parallel, just jumped, or in series, I guess, from the purple wire. So purple wire, resistor, onto that brown white. That fixed the ECU failure error, which was the most annoying one. The next thing that we did was we removed the side stand. This side stand sensor is some bullshit because KTM uses a CAN bus system. So the one way to dupe it is just epoxy a magnet and, you know, secure that. But I hate that because, you know, simplicity, that's what we're really going for, is I don't want crap like this on my bike. So this is a 3-wire thing. The other side on the bike is the same wire colors, which for some reason in this diagram are wrong. I don't really know why, but I think it's B30. Yeah, so we have red, pink, and yellow. Red, if I remember correctly, is just a hot 12. It might actually be a hot 5 volt for the CAN bus system. I don't remember. But either way, I think it's 12 volts. Just ignore that one though. You don't need that. You just need to jumper this pink and yellow with a resistor. I just threw, again, a 1000 ohm to massively reduce the current and heat. So that should be fine. That fixes your side stand error. Then you don't need a side stand, and you can put this in your garbage pile. The next thing we have is the EVAP, the fuel vapor valve, they call it, right? Oh, side stand connector, I guess, is right here in the harness. It'll be somewhere around there on your stock bike. So, yeah, next thing is the EVAP canister, which I thought I grabbed for the video here. Yeah, the workbench is an absolute nightmare right now. I want you to know this doesn't represent me as a person. Okay, you're catching me at a bad time. I can't find the EVAP canister. Whatever, I guess. Anyway, it's a little 2-pin connector on a black box, you know, with the vacuum line running in and out. It'll be mounted on here. There's the green, pink on one side of the connector, one wire in this 2-pin connector, and then the other side, I think, is brown white, the sensor ground. Like I said, this diagram's kind of iffy, but I'm pretty sure that's it, because brown white's all our sensor grounds. So again, 1000 ohm resistor across that, short it, give the feedback to, again, the ECU, whatever, a signal, so that it can think that something is there. That one, I will be testing the heat as I'm able to ride the bike and heat it up more and see if that makes a hot spot. If it does, I'll swap it out for a 5 watt, and I will put an annotation right now. So if there's no annotation, then that means that the these regular, what are these, like 1 watt resistors? Yeah, probably, those regular guys, are fine. Anyway, so that is how we delete the EVAP. Allegedly that causes an FI light. Like I said, I haven't actually ridden the bike yet. And I never rode it with that just disconnected, so I don't actually know what the warning looks like that causes that. I'm going to guess that it's just a check engine light, and then you'll need to check an OBD2 code. But anyway, that's how you remove that. And the last thing that we fully deleted, or sorry, that we had to do something with, is the clutch switch. That one's super, super simple. We got a black yellow, which is just a regular system ground, and a yellow green. I think those are accurate wire, what is it called? Wire colors, but I don't remember. Either way, clutch switch is pretty obvious, you know, it'd be right there. And it's not anymore because it's right here. Oh, I guess we can find the wires. Oh, is that a brake switch or a clutch switch? I think that's the clutch switch. If it is, that's weird. I don't remember. Either way, you know, it's going to be right there. Jumper those wires on the harness side. Literally just short them, so tie them together, solder them together, crimp them together. Like I said in the last video, I really recommend those heat shrink crimps for this kind of thing, just because heat. But if you don't put it at a hot part of the engine, you put it somewhere with decent airflow, honestly, solder's going to work just fine for you too. But yeah, so those are the 4 things that I actually had to modify on the harness to solve a problem. This ECU failure is the #1 one. I don't really know why the relay coil causes that, but it does. So if you want to do reduction and simplification on your harness, that's really what you need to know. All these are useful, but that one in particular. So that's like our main lessons learned here. And I think that is everything. So that got the bike to add no codes with my code reader during warm-up. Again, I haven't ridden it yet, so I will probably add maybe just a bunch of annotations at the end of this video if I learn more and I remember to add them, but that's the basics for now. The last thing that I did was fix the speedo. I might play with, you might be able to jumper this with the resistor as well, but I haven't screwed around with that much yet because I was really hoping that I could figure out how to retain traction control. I've not been successful with that. It still shows ABS failure and MTC failure on startup. But what I did was, because I just don't want this block shit. I don't know, again, I don't know why I'm doing all this, but I just don't want a bunch of bullshit in here that I don't need. I want the bike to be lightweight and simple, make troubleshooting or just generally working on it easier. I just don't want a bunch of crap there. Anyway, I gotta quit defending myself there. So what I did, and this is kind of mangled, was I cut around here with a hacksaw. Let me take this out so I can actually show you. Okay. I cut around the connector with a hacksaw, and you got to be super careful because, you know, there's pins through here. There's like a capacitor right here, and there's something else I don't remember right here. So yeah, cut across the top with a hacksaw, super careful. Cut around here. Or I might have split this with a chisel. I think I split this with a chisel because there's a seam between the back and the front here. And so I just sort of like gently hammered around it with a chisel and a paint scraper until that cracked off, the case cracked off the back. This circuit board is not attached to that back case, so you're not really in danger of fucking up the circuit board by popping off the back, assuming you don't hammer through the plastic here, which, as you can see, is only as thick as that little smudgy line there. So you do need to be careful. And then what I did, once you get that back case off and you get all this plastic shit off, the pump is attached because these are all the solenoid connections. So solenoid. That's basically to modulate your brake pressure, I think. And then the other side is the pump, which I took apart because I was just trying to figure out if I could actually like unbolt this in a clean way. And I was willing to destroy it because it's like 25 bucks on eBay. But yeah, so I got that plastic case off, and then I literally just took a pair of wire cutters and just sort of like carefully shoved them in and just cut the connectors. I was trying to figure out how I could release the solenoids and take the whole things out, but I just gave up. It was just too much of a pain in the ass, and this is testing. Like I said, they're cheap enough that who the hell cares? But yeah, so just having this circuit board though, will fix the speedometer or make the speedometer work. It references the front ABS sensor, I think exclusively. It might reference the rear too. I don't know, but it definitely references the front. So just having this circuit board connected will make your speedometer work. And then I just covered it in some of this kind of ghetto, but this liquid tape here. It does good stuff. I used to use this on racing drones, which would get crashed into the earth at 50 miles an hour. And it never really had a problem. It actually did a great job protecting. So yeah, I just used that. I'm probably honestly going to also cover this in duct tape and then just like zip tie it somewhere off to the side, which is not super professional. I would like to make a little case for it at a 3D printed stuff, but I don't think I have time. Anyway, that fixes the speedo. So yeah, in recap, you want headlight relay coil side jumpered with a 1000 ohm, side stand pink and yellow jumpered 1000 ohm, EVAP canister, the 2 pins on your harness jumpered 1000 ohm again, clutch shorted, ABS module destroyed, plugged back in. If I can figure out how to make traction control work, I don't think I'm going to be able to, because I think it's asking for the pumps and solenoid verification on the CAN bus system. So I think to do that, I would probably need to build like an Arduino that would actually talk to the ECU and send the CAN bus signal back and forth. And that is so much more work than I'm willing to put in on this. So yeah, this is what we're doing for now, but I'll make like a 4.2, 4.3 video on it if I figure that out. And very last thing is my bike went into limp mode because I was testing it with a bunch of stuff disconnected and chopped up, etc. Resetting in limp mode, it made it so the throttle it would move the valve when it was ignition on, engine off, But then once the engine turned on, I wouldn't have control with the throttle. I don't really know why the bike freaked out that much, but just resetting the OBD2 codes fixed that before I had fixed any of the wiring. I don't know why that is, and I don't know if that would fix itself just from idling long enough. And hopefully it doesn't come back. Really, hopefully it doesn't come back. Yeah, so if you get that limp mode while you're doing this kind of thing, you need an OBD2 reader, and you can get this little 6-pin adapter off Amazon. I don't remember what it's called, but it's just this like red adapter. I looked up like KTM OBD2 adapter, and you have this little 6-pin. But yeah, anyway, I'll catch you on the next episode. I'm on the time crunch. Like I said, I've been working way too damn much, so I've really cut this down to the wire. Right now we're April 14th on Tuesday. Probably shouldn't show you where I live, but whatever. Don't come here. And the first race is here on the 17th, I think. So, her first event, well, 17th or 18th. So we are cutting it down to the wire. Anyway, we're going to move on to actually mounting the fairings now that the bike seems to run well. Once we have the fairings mounted and the ergonomics all built up delicious, then we'll go do some test rides and make this thing hot and make sure that everything actually works as it's supposed to. Anyway, thanks for seeing this episode, and I will catch you later.